Good evening, everyone. Welcome to the training session, Economic Feasibility of Rooftop Solar for Commercial and Industrial Consumers in Tamil Nadu. In this session, we will inform you about updates on Tamil Nadu solar energy policy, briefly explain the applicable metering mechanism and simulate demo scenario using an online rooftop solar. One second. Rooftop solar developed by Auroville Consulting. Later in the session, we would like to brief you with some further advancement that we have planned for Solsavi. I would like to inform you that this session will be recorded, as this session would include working with the web tool. It is advised to use laptop. Polls will be conducted to receive feedback from the participant. We encourage you to ask your queries through the chat options or during the question and answer session. The session will be presented by Frano De Silva and Meg Patel. Both Frano and Meg are renewable energy analysts at Auroville Consulting. Before starting the session, we would like to know the professional background of our participant. The pool will be visible on the screen and please select the appropriate option. Thank you all for answering the session. I would like to take over. I would like to Frano to take over and continue the session.
Good evening, everyone. Welcome to the webinar, Economic Feasibility of Rooftop Solar for C&I Consumers in Tamil Nadu. I am Frano De Silva. I work as a renewable energy analyst at Auroville Consulting. For today's session, we will take you through an agenda that would take you through a journey of designing an economically feasible rooftop solar system. Initially, we will give a brief of the policy and introduce the Solsavi web tool. We will conduct demo scenarios and have result discussion on those demo scenarios. We will end that session through a Q&A session where we can discuss further on the web tool as well as the scenarios that were simulated. Further, we'll be introducing a Solsavi vendor portal and and end it with a small Q&A session regarding the vendor portal at the end of this session. Here, I would like Meg to launch the first poll where we will be asking on what information is available in the solar policy. Can you please, it is a multiple choice question. I repeat the question again. What are some of the information you get from a solar policy? You can select multiple answers and I will wait for most of the participants to answer the queries. The options are, can we find out about applicable metering mechanism, my specific rooftop solar system size, applicable feed-in tariffs, financial returns from my installation. I'm waiting for a couple of more answers from participants. If the poll is not visible to you, you can let us know through the chat so that we can rectify the error. I see that 75% of the participants, 80% of the participants have answered, and I shall end the poll here. As you can see the results, 50% believe that they can get the applicable metering mechanism. 30% of the answer says they find the specific rooftop solar system size from the solar policy. You can find out 40% think applicable feed-in tariffs can be found out from the solar policy, while 60% answers say that financial returns of my installation can be found from the solar policy. I would like to point out here that the most legible information that you could get from a solar policy are the applicable metering mechanisms and the applicable feed-in tariffs, while your specific rooftop solar system size would have to be calculated from the boundary conditions such as the maximum PV allowable in that region or in that solar policy. And also you might not get it the financial returns from your installation. However, the feed-in tariffs will definitely influence your financial returns from your installation. So you will definitely get metering mechanism as well as feed-in tariffs from your solar policy. I'll stop sharing the screen now and return to the presentation. With regard to the TN solar policy and regulation, the solar energy policy was revised in 2019. Supporting to that policy, a generic tariff order was released for grid integrated solar systems in 2021, which introduced net metering mechanism for domestic consumers. As you can see from the table, where we have marked the tick marks for applicable metering mechanisms for the categories in LT as well as HT category. With LT, I mean low tension, and with HT, I mean high tension category. As you can see, domestic metering mechanism is applicable only for domestic category, and gross metering is applicable only for generators or system sizes which are larger than 150 kilowatt. I hope the screen is visible and you're not facing any issues.
Frano, we can see only the main first slide. It is not changing.
Let me stop and share again. Is the screen visible now to all the participants? Thank you. So to continue and to restart again with the solar energy policy, the Tamil Nadu solar energy policy was released in 2019, and the supporting regulation for solar policy was the generic tariff order that was released in 2021. From the table in the slide, you can see the applicable metering mechanisms for different categories under low tension as well as high tension consumers. The net metering mechanism is applicable for domestic consumers only, while gross metering is applicable for HT consumers having a sanction load or a connected load above 150 kilowatt. While net feed-in mechanism is applicable for all the categories in LT as well as HT consumers. Other features that included in this generic tariff order was the introduction of network charges and premium charges for export during peak hours. That is, the peak hours are in Tamil Nadu are from 6 a.m. to 9 a.m. and from 6 p.m. to 9 p.m. in the night. As well as with introduction of tariff category, we had the tariff revision for net feed-in mechanism. As you can see from the table, the net feed-in mechanisms for LT category C&I consumers as well as HT C&I consumers for varying PV capacity sizes. The feed-in tariff changes for different PV capacity sizes that you install, and depending on the size that you select and have installed, your net feed-in tariffs will vary. To do a simulation or to make an analysis of how much rooftop solar is required, according to the policy, there are certain terms and nuances that we must be aware before doing the simulation. Here on this slide, we present an HT bill in Tamil Nadu, where we can see the applicable period of that bill, the consumer category, the sanction load for that consumer or for that connection, the tariff that is applicable for that consumer category, the units that are consumed in that particular applicable period, as well as total electricity bill. Taking all this information, we must also understand what our consumption is and how our consumption can affect the installation of rooftop solar. Hence, to explain briefly how we have determined consumption using the Solsavi web tool and what calculation or rather what logic we use to convert the information that you have given into a consumption profile in Solsavi. On your screen now is a consumption profile for one day, that is 24 hours. And this consumption profile, in the graph, you can see the blue shaded area which shows the consumption profile during those 24 hours. In this consumption profile, you can see that maybe around 7 o'clock in the morning, the consumption begins from the minimum load, where you could say that this particular connection has some consumption from 7 to 10 a.m. and at 10 a.m. the consumption begins to rise till evening 6 p.m. and at 6 p.m. to 10 p.m. in the night, the consumption lowers down, finally going to minimum load at late night at 11 o'clock. What this means is this could be an industrial consumer who works primarily between 9 to 6 and has some activities going on between 6 p.m. to 10 p.m. finally going to minimum load throughout the remaining hours. For this, the monthly load we have assumed to be 990 units per month, which turns out to be 33 units per day. And how do we divide and ask you to report your consumption? We have divided the 24 hours in 4 time sections, where they are 6 a.m. to 10 a.m., 10 a.m. to 6 p.m., 6 p.m. to 10 p.m., and 10 p.m. to 6 a.m. These 4 time sections are then allocated certain percentage of consumption during that day, such as in this case, a 50% consumption between 10 a.m. to 6 p.m., a 30% consumption between 6 p.m. to 10 a.m., and the remaining percentages are shared between the other time section. So this allows us to formulate a daily average consumption, and then this can be extrapolated and given a consumption profile for the whole year with an hourly interval. So now that we realize that this is our consumption pattern and this is how we enter or input the consumption pattern in Solsavi, what is the impact of introducing a rooftop solar on our consumption or in our area to use the solar energy for our consumption. In this slide, as previously noticed, the blue shaded area is what the grid contributes to the load. And if you can see, the red line indicates the total solar generation in that day, while the green shaded area shows how much solar energy has been self-consumed to satisfy your consumption between the solar hours. And in between those solar hours, in case your consumption has been satisfied by solar and you still have excess remaining, the orange hashed line shaded area indicates the export to grid in this graph. Taking the case where we have still the daily average consumption of 33 units, initially all 33 units was satisfied by consuming from the grid. However, with the introduction of the solar system, we can see that the grid contribution has reduced from 33 to 21 units in that day, and the solar system then contributes the remaining 12 units that are needed for the consumption during solar hours. Additionally, we can see that the generation produces 6 extra units in the day, which are then exported to grid to generate revenue. Initially, to do in a BAU analysis, to do the electricity bill, we would calculate just the total units supplied by grid into our grid tariff, because all of the consumption is fulfilled by grid supplied energy, and hence that would be our bill calculation. However, with the introduction of solar panels and self-consumption being considered to reduce our grid consumption, we need a different type of energy accounting. And as earlier mentioned, the solar policy gives us 3 main or 3 metering mechanisms that are applicable in Tamil Nadu. The 3 metering mechanisms or solar metering arrangements that are applicable in Tamil Nadu are displayed in the slide, which are net metering, net feed-in, and gross metering. The arrangement for net metering and net feed-in are similar and can be seen at the left bottom of your screen, which employs a single bidirectional meter which records the grid supplied units, which are determined here in the slide as A, and records the export to grid units, which in this slide are determined as B. The compensation for net metering is done through grid tariff. That is, if you see the calculation, the grid supply units minus the export to grid, that is how much you have exported to grid. The difference of these units are then multiplied with the grid tariff to find your bill. While in net feed-in mechanism, the bill calculation happens separately for the grid supplied units on grid tariff, that is the grid units multiplied by grid tariff, and a quantum of energy, that is the export to grid multiplied by the net feed-in tariff, is then subtracted from the grid tariff, because when you export, you generate a revenue from this, and which has to be negated from your actual consumption. In net metering and net feed-in, there is a possibility of self-consuming energy and satisfying your load through the energy that is generated from the installed solar system. However, in gross metering, from the arrangement, you can see that we employ 2 meters, that is an import meter and an export meter. The import meter is used to record the grid supplied units indicated by A, and the export meter is used to record the exported units to grid indicated by B. The calculation for gross metering is done in the way that the grid supplied units are multiplied with the grid tariff, while the export units are multiplied with a gross feed-in tariff. And the second portion is then negated from the grid consumption amount to arrive on the total bill. To further show you how the billing mechanism happens with these metering mechanism, especially for net feed-in and gross metering, as they are applicable to the C&I consumers mainly, we have taken some examples. In this slide, we will show you the net feed-in mechanism for a monthly requirement of 1000 kilowatt units and monthly solar generation of 600 kilowatt hour units. As your solar generation generates 600 units, with the introduction of solar system, the grid units have reduced to 550 kilowatt hours, and the remaining 450 kilowatt hours is supplied and self-consumed from the energy generated from the installed solar system. The remaining 150 units from the total 600 that has been generated is then exported out to generate revenue. In this case, we have taken the consumer category of industrial HT, who has a 6.75 rupees per unit as a grid tariff. In the BAU case, you would calculate the total requirement or the units consumed from grid, which would be 1000, into the grid tariff, that is 6.75, giving you a bill amount of 6,750 rupees. While having installed a rooftop solar and adopted a net feed-in metering mechanism, the energy accounting in this case is done by taking the grid supplied units, that is the 550, into your grid tariff and calculating the revenue generated by export, that is 150 units, into your net feed-in tariff, which is then negated with the amount that you have incurred for consuming units from grid, which amount to 2,987 rupees. The difference will then be a saving for you in that month from installing a rooftop solar. In the case of gross metering, as mentioned earlier, there is no self-consumption in gross metering. Hence, the gross generation or the total generation from the solar system installed is exported to grid to gain or earn revenue. In this case, as you can see, the energy accounting here is that grid supplied units is multiplied with the grid tariff. So it would be 1000 units that are required, are supplied from the grid. Hence, it would be multiplied by 6.75. While the quantum of gross solar generation, 600 units, is multiplied with the grid, with the gross feed-in tariff, which is 3.1, and then negated towards the amount that is gone into consuming energy from the grid, which gives a total amount of 4,890 rupees. However, we would like to point out that this would not be the end of your bill calculation, as earlier mentioned that in the generic tariff order released in 2021, a network charge was introduced. What is this network charge? Well, this network charge is a grid support charge for usage of electrical network as a support mechanism for generating as well as transmitting the power from your solar system. The network charge is levied on the gross generation of the energy. That means the total solar generation is subject to network charges, which is both the quantum that is self-consumed and the quantum that is exported to grid. The gross the network charge is applicable for net feed-in mechanism. However, there is no network charge applicable for gross metering mechanism. The charges are as shown in this table, which are 1.48 rupees per kilowatt for an LT consumer under net feed-in mechanism and 0.96 rupees per unit for an HT consumer. So the bill calculation then further changes. As you have seen, the 2000 under net feed-in mechanism, the bill amount was 2,987, and inclusion of network charge, which would be the gross solar generation units into network charges, that would be 0.96 for an HT consumer, will amount to 3,563 rupees as compared to 6,750, which would have been to be paid in business as usual case. While for gross metering, there is no network charge. Hence, the bill amount remains the same as the previous calculation. Moving further to show you what we have considered as an optimization criteria in Solsavi, we consider three main criteria, that is to maximize avoided cost, to maximize savings, and minimize payback period. While considering these criteria, it is important to consider some parameters such as the amount that you would self-consume from the installation, what quantum of units would you export to grid, and what quantum of units would you import from grid. To give an idea of how the optimization is considered also with avoided cost is shown in this graph, where if we consider the HT industrial tariff, which currently is 6.75, that is close to 7, and can be easily assumed or safely assumed that it would grow linearly or to a certain percentage over a period of years in the future. While if you install a rooftop solar, we see that the levelized cost of energy would be between 5 to 6 rupees currently, and this levelized cost of energy remains the same for the period or the lifetime of your system. Hence, you would not be paying more for the quantum of energy that is generated from your rooftop solar system. Therefore, the area between these two lines will potentially be your savings after installing rooftop solar and using the energy generated for your consumption. After deciding and understanding how the optimization as well as the bill calculation takes place in Solsavi, we move to find out from you and to inform you what are some motivations for installing rooftop solar systems. According to us, there are three main motivations to install rooftop solar system. One could be the legal aspect. In Tamil Nadu, the building code regulation from TNCDB has a mandatory installation requirement of solar energy system in high-rise buildings and non-high-rise buildings, having a dedicated area on the roof for solar energy systems. Additionally, the ECBC has also put requirements to accommodate mandatory installation of rooftop solar systems. Another motivation could be an environmental motivation, where we are having lower emissions from the electricity that we consume generated from a renewable source. Some companies have a mandatory ESG reporting, and lowering your emissions as well as consuming electricity from renewable sources will be a bonus for reporting your environmental social governance. Lastly, we also think there are financial benefits of installing rooftop solar, such as savings in long term, as well as avoided cost from switching to rooftop solar, and lower generation costs in terms of the LCOE determined by the rooftop solar installed. At this point, I would ask my colleague Meg to launch the third poll, where we try to understand what are some main reasons to refrain or back out from installing rooftop solar. This is a multiple choice question, so you can select more than one answer if you think whichever is applicable to the main reasons to refrain or back out from installing rooftop solar. The options are financial support. We are unaware of available credit lines. We find it difficult in identifying a solar installer. The calculations for designing a rooftop solar are quite complex, and we are unsure of the financial returns from rooftop solar. Which do you think are main reasons to refrain or back out from installing rooftop solar? I see that 80% of the participants have answered, and I wait for a couple of more to finish the poll. I would be ending the poll now and sharing the results. As you can see, 58% of the results say that they are unaware of available credit lines or the financial support for rooftop solar. 50% of the answers indicate that it is difficult in identifying a solar installer. 42% think that the technical calculations are too complicated, and 67% answers indicate that they are unsure of the financial returns. I would like to inform the participants that with the complexity of the technical calculations and the financial returns from installing a rooftop solar, these two aspects can be tackled by the Solsavi web tool, which does the calculation of a 25-year analysis, as well as shows you a return and financial parameters that can help you make decisions, which we will come to later. And for financial support, information on credit lines, we have written a blog, and we are developing a blog which will make the reader aware. And we could share this blog in the chat, which you could use to find out more about the financial or the credit lines. With the difficulty in identifying a solar installer, maybe at the end of the session, Meg can inform you a little bit more on how we intend to tackle this issue, and we take it from there. I will stop sharing the results now and continue with the presentation. We come on the decision-making process. That is, if I have to install a rooftop solar, I would first have a conception of the project. That is, I would think that, yes, I want to install a rooftop solar. Secondly, I would come to the feasibility and check how feasible would this rooftop solar be for my consumption and in my location. I would then give it to design and install the system while maintaining and operating the system to its best efficiency and performance. However, I would like to point out that during the feasibility or during checking for the feasibility of the project, we need to ensure that we have an alternate opinion. We need to know how the generation pattern from the installed rooftop solar would be. And we also would have to estimate potential savings and investment requirements for the rooftop solar. However, the critical part is that we need to do this quickly. And this is where I introduce Solsavi, your rooftop solar calculator. How can Solsavi help? From some existing tools, we have noticed that the tariff that are mentioned is either specified as a single tariff. However, most of the categories under the tariff order have a multi-tier, multi-slab tariff, and these tariffs are not usually updated in the existing tools. However, in Solsavi, we have taken care that we try to update the tariff as they are revised and the policies as they are changed by each electricity regulatory commission. In some of the tools that are available, we also find it difficult to find tools that include battery storage. In Solsavi, we have tried to give you two choices for the technology of battery storage that you can select and do an analysis for the lifetime of 25 years. Some of the tools that are available online are developed by solar developers, which then comes into a conflict of interest, while we have tried to remain industry neutral while designing the Solsavi web tool, and that way we try to give you a fair and unbiased calculation and suggestion from the rooftop solar. We do a 25-year analysis of the system, and as financial outputs, we give a potential savings, payback, and return on investment from the rooftop solar system. To make you familiar with the workings of the Solsavi tool, we have designed two scenarios. The first scenario, I will conduct this first scenario myself and take you through some of the features of the Solsavi web tool. The second scenario, I would encourage the participants to work it along with me, where they can then understand what inputs need to be given and how each input need to be entered for the simulation. In the demo scenario 1, we will try to simulate a commercial building with a sanction load of 120 kilowatt and a solar plus battery system under net feed-in mechanism. The average monthly consumption would be 10,000 with a peak capacity of 50% between 10 a.m. to 6 p.m., having a battery technology of lithium-ion battery. Here, I would stop sharing my screen and switch to sharing the screen with the Solsavi web tool. I hope the screen is visible to the participants. It will be great if someone can confirm it through the chat. Thank you. This is the landing page of the Solsavi web tool. We have a short video to show you how the calculation can be done, a send message button to get in touch with the Solsavi team in case if you have any queries. You could subscribe to our newsletter by clicking that button. We have a blog page where we try to keep this updated with relevant topics. We have an FAQ page where we have selected some common questions that you might find answers to on this. However, To begin your simulation, we press the Get Started button in the middle of the landing page. While pressing the Get Started button, it takes us to the demographic page where we define the location by entering the PIN code. As you enter the PIN code, we give us limited details of where this PIN code belongs to, and through this information, we access the weather files for that location to do further simulation. Under the Tamil Nadu area, we have these consumer categories, and for our simulation, we have taken the commercial category under high tension voltage. To show you how the decision making happens in Solsavi, in case if I select a domestic consumer, you see that the HT voltage disappears because low tension is domestic consumers are applicable under low tension voltage only. However, for this demo simulation, we take the commercial consumer under high tension category, and to proceed to define the policy requirements, we click next at the bottom of the page. Under the policy page, we can define the applicable metering mechanisms. As we have considered net feeding for this case, we select net feed-in and select the solar plus battery technology for our case of demo scenario. We click next to further define our consumption. As shown earlier in the presentation, we have given a place to enter your sanction load, which will influence certain parameters in the billing mechanism, as well as deciding your PV capacity. In this case, we enter 120 as our sanction load. However, I would like to show the participants that in case you have selected an HT connection under Tamil Nadu, we have the HT limited between 113 kilowatt and above. Hence, if you enter a value less than 113, you will get an error message which will urge you to maintain a value above 113. Continuing by defining the sanction load as 120, we then further move to define our electrical consumption. We have two options to define our electrical consumption. Either we give an average monthly where we enter one value for the average of 12 months, or we can enter a monthly consumption value for each of the months in the year. For this case, we select the average monthly and enter 10,000 units for this scenario. As indicated in the slides, the peak consumption for this consumer is between 10 AM to 6 PM at 50% being consumed in those hours, 30% between 6 PM to 10 PM, and 10% each for other time sections. As you can see, if the sum of the percentage that you have selected is not 100%, then you will get an error message urging you to have a sum of 100% as your distribution, as your consumption percentage, which then defines your load that is distributed in 24 hours. As it's a commercial unit, we would say that the consumption pattern would vary on weekends. Hence, we can define yes, select yes, and proceed further to define the consumption weekend by clicking next at the end of at the bottom of the page. At this junction, I see a question regarding the simulation with a monthly average of 10,000 units, because we say that the average of this consumer is 10,000 units per month for the whole year. I hope that is clear and not confused. We can come back later to the simulation and discuss this once we are done with the simulation and results. To proceed further on defining your consumption weekend, we have the consumption pattern where we say that during the weekend, 40% of the consumption happens between these time section, 30% between the 6 p.m. 10 p.m., 20% in between 6 a.m. 10 a.m. and 10% for the remaining time session. As indicated earlier, we think that maybe the weekend consumption is lower as compared to weekday, and say that it is 50% lower. If you think that your weekend consumption is higher than your weekday, we would then select a higher percentage. I see a hand raised. However, I would request that we keep our questions either in the chat or ask them after the simulation while discussion of results. I hope that is okay. To continue with the simulation, we take a lower 50% lower consumption as compared to weekday and click next at the bottom of the page to define our technical calculations. The battery technology available here is lithium-ion battery as well as advanced lead-acid battery. The details of the batteries that we have considered are visible in the I buttons for each of the battery, and what are the values that we have considered are taken here. For this case, we take the lithium-ion battery, and as soon as we click the lithium-ion battery, we see that the system financials are populated. These system financials for the solar system, the inverter and the battery system are taken from research or from benchmark costs released by MNRE. The additional input for battery would be to define your dispatch strategy. That is, when do you want to charge your battery and when do you want to discharge your battery. If auto is selected as shown in the I button, the charging hours would be from 10 a.m. to 4 p.m. and the discharging hours would be between 6 p.m. and 10 p.m. However, if you want to define your own charging time, let's say I would want to charge from 9 in the morning till 4 in the evening and discharge from 6 in the morning to 10 in the evening. Please note that the values should be entered in 24-hour format in this section. As you can see in the system financials, we have also given a place for subsidy. And in case if you have a subsidy or you can avail subsidy, and in this case, we say we have 1,000 rupees per kilowatt subsidy. We can enter the value and you can reflect the change in the total cost. Clicking next would then proceed to define this solar capacity that you would want to install. In this case, I would like to show that, as mentioned earlier, the sanction loads is an indication of how much solar panel you can install. As we have given 120 kilowatt, we see that when we enter a solar capacity above a sanction load, it prompts an error saying that our solar capacity cannot be above 120, which is our sanction load. Hence, we select the maximum PV capacity that is allowable. With the battery capacity, we have allocated a ratio of the 2 times of the solar capacity, imagining that you would at least require minimum of storage, possibility of having a 2 times of your solar size in case you are able to invest in battery. However, to show you the limitation, I have entered a higher value to see that the maximum allowable for battery in Solsavi would be 2 times of your solar capacity. This is just a suggestion to manage the minimum 2 hours dispatch that we would require from the battery. However, it's just a suggestive value and do not take them as standard values. To run the simulation for the selected and desired sizes, in this case, the most maximum possible, we run the calculator and wait for a few seconds for the results to generate. For the selected solar capacity and the battery capacity, which are mentioned in the below, we see that the return on investment is a mere 2.41%, having a very high payback of 13 years. This could be desirable for people who are looking to base most of their consumption from solar. However, having a financial investment is quite huge for the solar system. We have in the detailed report, we have multiple results that I will take you through briefly, where we can see that the inputs that you have entered are visible, as well as the consumption profile that you have taken and considered. As today is 22nd, which is a Thursday, a weekday, we can see that most of the consumption is during these hours, and you have got a higher consumption during 6 to 10. However, to show that we can select a range, and you can see that 50% lower consumption is visible on weekends as compared to weekday. Moving further, we see that the results on the left, you can see the system size that you have selected, that is 120 kilowatt of solar system size and a battery capacity in kilowatt hours that supplies 240 units would have a power capacity of 120 kilowatt with a minimum discharge of 2 hours. This system would require 1,200 meters square of area to be installed. The total investment is given in the right table, which are then bifurcated between solar system, inverter, battery, and the subsidy that is applicable. The financial parameters such as payback is indicated, the return on investment, what is your average annual savings for 25 years, the total 25 years saving, and the percentage of saving in 25 years with respect to the BAU case. The graph on the right shows you the comparison of electricity bill with system and electricity bill without system for a period of 25 years. So you can then compare and see what you would have paid if you had not installed a rooftop solar system and what you pay in case you install a rooftop solar system. Finally, coming to the last results, we see that this system which is installed supplies or contributes to 51% of your load from solar and 25% from the battery, while 48% of gross solar that is generated is exported to grid. That is the percentage of total power generated by the installed system. And from grid, you are consuming only 23% in this case. We can select from the graph here, you can see that this is the portion that grid supplies during a day, that is the 22nd. This is what your solar system supplies throughout the day. as a self-consumption. This is the portion that is exported to grid on this particular day, and battery supplies to you in the evenings, reducing your load that is supplied from grid. We can select any particular day to see how our system behaves in that particular year and see what is the contribution of each of the system to satisfy your load. We can export, click this button and export this as a PDF and take this as a reference to compare or to show a power developer that this analysis has been carried out using the tool, and this is the result that has been expected from the tool. I would like to show that there is a click here button which takes us to the assumption page, where we have detailed out all the assumptions that are being considered for the simulation. Clicking back to results take you the result summary page, and in case if you want to change anything in your simulation, I can press the revise calculation button, which takes me back to the demographic page, and I can make changes in whichever section I want to see how it impacts my analysis, such as if I have only 500 rupees as subsidy, I could make that change. I could click next. I could say I want a lower battery capacity and say I want only 30 kilowatt hours or 60 kilowatt hours, and run the calculator to see how different this calculation would be. As you can see, with a solar capacity of 120 kilowatt and a battery energy capacity of 60 kilowatt hours, the return on investment increased from 2% to 5%, and the payback reduced from 13 years to 8 years. In this way, you can find out the system that is feasible for your location and the investment that you could do to install the rooftop solar. I would stop sharing this and return back to the presentation to give you a few details on how we are considering the next scenario. I hope the screen is visible. In the results, we have seen the annual savings, the payback, the system cost, and return on investment, while the technical details shows the solar and battery capacity, the average daily solar generation from the system for that year, as well as the avoided emissions from the installation. For the second scenario, we will try to simulate an industrial warehouse with a sanction load of 55 kilowatt and a solar only system, in this case under net feed-in mechanism. As you can see, the peak consumption would be between 10 AM to 6 PM, and the others distributed between other time section. I would ask Meg to share the Solsavi link in the chat, and you can then follow this link and open Solsavi web tool on your screen. While I share the screen with the Solsavi web tool and do the simulation for the second demo scenario. If you have reached the landing page, please confirm in the chat, which will help me to go together and take you through the presentation. So if you have reached the landing page, you can click the Get Started button to find the demographic page. Under demographic page, we again give a pin code of Chennai and select industrial consumer under low tension category for this simulation. You can click next and then go further to define your policies. Under industrial consumer, under Tamil Nadu, for an industrial consumer, under LT voltage, we find that metering mechanism applicable is only net feed-in, and the technology that we want to simulate is a solar only technology. Making our selection, we proceed further to define our consumption by clicking next. Here we have a sanction load of 55 kilowatt in this case, and as indicated before, if I enter a value above 112, which is the limit for an LT load, I will get an error message. Here I would like to take the questions that have been entered in the chat, that is asking if the monthly average is the average consumption for the whole year, that is the 12 months. Yes, here you would have to enter an 12-month average unit consumption for your location or your consumption. I hope that clarifies the doubt which few people had with the value that was entered in the average monthly. In this case, I would enter 5,500 to be the average 12-month average for this consumer. Moving further to define our consumption, we say that 50% of the consumption happens between 10 a.m. to 6 p.m. and 20% in the morning between 6 a.m. to 10 a.m. and 20% between evening 6 p.m. to 10 p.m. followed by 10% at the remaining time section. As this is an industrial warehouse, we say that it would definitely have a different consumption pattern in the weekend. We click yes and click next to define the consumption at the weekend. Assuming there are housekeeping activities, we say that 30% of the consumption happens in the morning. The peak consumption with 40% happens between 10 a.m. to 6 p.m. 20% between 6 p.m. to 10 p.m. and 10% in the night hours. With 75% lower consumption during weekend as compared to weekday, we proceed next to define the technical calculation. As this is a solar only case, we see that the system financials are the only selection to be done, and there is no selection for battery as well as dispatch strategy of the battery. We say that there is no subsidy applicable for this consumer, but however, we would like to change the per unit benchmark cost that are suggested here and say that we would enter a higher benchmark higher solar system cost because we have received this per unit cost from a solar developer. I just want to show that this value can be changed in case if you find you have a value that conflicts with the suggested benchmark cost that have been suggested in the Solsavi web tool. We click next to further define the solar capacity, and I would like to address the question here that is asked in the chat, that is maximum allowed solar PV capacity for consumers in Tamil Nadu up to 100% of the sanction load. Yes, and that is why we have kept a limit where we cannot enter a PV capacity or the solar capacity above your sanction load. That is the main reason why we have entered this category. Taking maximum PV capacity, we run the calculator and await results. As you can see, for this consumer with a 55 kilowatt solar capacity, we find that the return of investment is 10% and the payback period is 6 years. To go and find out more detailed report, we can find out our consumption by selecting particular day. As today is 22nd, I would select 22nd. My apologies, I have selected a range here. I can go back again and select the day and see that the peak consumption happens between 10 to 6. I can select a range and see how it varies to weekend as compared to weekday. I can see how much shade-free area size I require to install the selected solar capacity, what investment I need to install this system, what is my payback period with the return on investment, as well as percentage of savings in 25 years. I can find out the comparison of electricity bill with system and without system in cases from first year till the 25th year of analysis to show how much savings have been incurred by installing this rooftop solar system. We see that 50%, 55% of the load is taken by the solar energy generated, and that is self-consumed, while 44% is supplied by grid. However, we can also see that 51% of the total solar energy generated is exported to grid in this case. You can toggle between the dates of that year and find out how your system has contributed to satisfying the load and how much quantum has been exported to grid. You can export this result as PDF and use it to show your solar developer or even at banks, because they include payback and return on investment and the potential of showing how much savings can be done throughout the lifetime of the system. Here I come back to the assumption because there was a question in the chat with having a having the maintenance cost for the system. We have taken in this case, as you can see, that the PV and inverter O&M cost is 500 rupees per kilowatt per year and a battery system of 500 rupees per kilowatt per year. These assumptions are fixed and cannot be changed. However, we are looking at options to be provided to user where they could eventually change assumption. However, we have to still integrate this change and allow the user to change the base assumptions taken in Solsavi. I also have seen a comment where you could explain, where some Sandeep Raju asked me, can you explain for a domestic consumer? Just to breeze through this, I can select a domestic consumer, which tells me a low tension, and we can select net metering while selecting different property type, solar type technology. Let's say you have a 5 sanction load with a 550 monthly average, having a peak consumption during your evening hours where you consume the highest electricity. Let's say for the sake that we do not have a different consumption pattern during the weekend, and proceed further to define your system financials, and then proceed further to see if a maximum solar PV size is selected, what would be the results. However, you can find out these results by selecting domestic category and then do the simulation for your consumption pattern and see which solar system then offers you the most benefit. I would like to stop sharing the screen here and go back to the presentation. I hope the screen is visible now to participants. And now I would like to invite some questions. First, I would take the question that has been raised by Nitin. Does the analysis include grid cost for consumption during peak hours? And wouldn't the installation of solar reduce the peak hour demand, especially for industrial or commercial consumers? If I understand your question correctly, Nitin, you mean to ask, have we considered time of day tariffs? And taking into consideration the time of day tariff, won't it reduce the peak hours during those time of day, especially for industrial and commercial? Yes, we have considered time of day tariff. We have in Tamil Nadu, we have some categories that fall under time of day for whom the time of day tariffs are compulsory to take and optional. In case if they are compulsory, we do not allow the selection for the user on the front end, assuming the user is aware that they fall into time of day category. However, if the time of day category is optional, we do provide this in the front end so that the user can make a decision whether to select the time of day or not. Any other questions that the participants would like to ask can ask now. For the requirements of subsidy, I can say that there is a central financing assistance that gives you subsidy for 1 to 3 kilowatt system and 3 to 10 kilowatt system. However, other subsidies will have to be checked depending on the state policies on for that particular state and the applicable and the subsidies provided by the government from that particular state. We are trying to build up the blog to give you these details, and you could then refer to those blogs or or visit our blog site to see if we have updated these requirements. With the angle of installation, we have assumed, I'm sorry, I will share the screen again. Apologies. Just find coming back, I hope the screen is visible. Coming back to the question raised, that is the angle or direction of installation. We have taken standard angle and tilt angle for the locations, and we have not allowed the user to change these locations. We see that there is a question also on designing part of modules and inverters. We have refrained from giving actual designs on the the connection or the electrical connections for the solar systems with the inverters, apart from defining the sizes and base assumptions, because we thought that the main problem to address for the users is to find out what is their financial return from installing this system, and then eventually contact a solar developer, as the solar developer would then inspect the site and then help you design the solar system that can be installed in the way that is specific to your location. I hope that answers your question, Mr. Soma Sundaram. If there are no more questions, I would like to proceed to the next part of the session. I see the tilt angle that we have selected is 13 degrees, and we have kept it standard as it does not vary a lot in Pan India. For the question that Nitin asked, the accuracy of grid tariff can be relied on for any pin code. Yes, Nitin. What we have asked is, what we have taken, what we have done is we have created a database for all 36 states and union territories of India and included tariffs for categories domestic, industrial, commercial, institution public, institution private for all these 36 states and union territories. We are in process of installing updating these tariffs as they are updated recently, and we will try to keep them updated so that you can get an accurate grid tariffs are considered to get an accurate results. Mr. Sandeep, maybe I can have a discussion with you at a later end where you could reach out to me through the send message or the contact that is provided later, and we can have a detailed discussion on how we have designed, taken the angle, the solar panel installation for our simulation. Due to time constraint, I would like to proceed to the next session. Please reach out to us and we will try to answer to your queries as soon as possible. For Mr. Somasundaram, quickly, the module costs that we have considered are the benchmark costs released by MNRE, that is the Ministry of New and Renewable Energy. If you could reach out, I could share to you the document as well so that you can take reference of these benchmark costs at a later time. However, moving further to the next portion, that is the Solsavi vendor portal. Here we have recognized that there is a need for a vendor for user to contact the vendors, and we also wanted to find out what are the problems that these vendors face. And here I would like to stop sharing the screen and ask my colleague Meg to take over and present this session. I will mute my mic and ask Meg to continue.
Good evening, everyone. I hope my screen is visible. Can someone confirm? Yeah, okay. So, as my colleague Prano already briefed you about this Solsavi vendor portal, that we got this feedback from our previous polls and webinars and trainings, that there was a need of portal wherein consumer can get vendors and financiers, lenders, and some more details where they could proceed further and take steps towards installing a solar rooftop. But before moving forward, I would like my colleague Prano to launch a poll which would basically ask you about what are the common ways to identify installer after getting or after checking a financial feasibility. So I would like you to answer the question, and based on the result, we'll move forward towards Solsavi vendor portal. So I'll read out the question for you. What are some common ways to identify a solar installer for rooftop solar installation? So ask a friend, ask Google. There's a new option right available now, which is ask ChatGPT also. And fourth one is research, find, compare, identify, and then contact multiple vendors. So I would like you to fill up this poll, and then we could quickly proceed to how this vendor portal will work and what are the features we are planning to add.
Meg, I think your voice is a little low. Can you please speak up so that the participants can hear you?
Sure, Prano. Is it up to the mark now? Thank you. So I think we should close the poll and share the result. Yeah, so we can see that 100% of the people, like 100% result says that we should research, then find, compare, identify, and then contact multiple vendors. So with that feedback, I would like Pranav to stop sharing the result, and I'll quickly give the brief that before this, we can see before we have asked a question before also that what are the uh, what are the pain points you face before moving forward to uh, installing a rooftop solar, wherein like we got this result that identifying a vendors and identifying financial options where the reference which customer generally faces before moving ahead. And this poll also says that finding a vendor or doing a research and finding a vendors would be a better option. So with that, I would like to move ahead with what are the features or what are we planning with Solsavi vendor portal. So Rano, can you stop sharing the result? Yeah, so we are planning to add a button on the brief analysis page, which will be like list vendors. So after doing financial analysis, after getting the result, financial feasibility result, there will be an option to
Meg, there is still a request to speak a little loudly, so maybe you can be closer to the mic and speak a little loudly.
is it clear now?
Can someone please confirm if they can hear?
Okay. Yeah, so after getting into financial Solsavi result page, brief result page, we are planning to add a button which will basically it will be a list vendor button, wherein after clicking that, it will be redirected to a new page which will land to a Solsavi vendor page. So I hope you can see the portal. So this is the landing page of Solsavi vendor portal, wherein you will be briefed with a map view, which wherein you can see the vendors that are based on the location of where they are. So if we have further narrowed down, so we have given some filters options like location and category. So if let's suppose we enter some let's take Chennai as an option. We have to type any city and then select the city. So based on location entered, you will find a list of vendors in the map also, and also there will be a list below wherein you can find multiple vendors. There is an additional filter wherein you can select the category based on if you are looking for domestic, if you are looking for commercial, and if you are looking for industrial. So you can select that. Right now, I'm not selecting any category. So you can see there are two vendors in the location which you have selected. It can be specific to your district also. It can be specific to your pin code also. So right now I've entered Chennai, and there are two. These are the demo scenarios. It is not being. We are not live this portal. This is just to inform you that we are planning to introduce such thing. So these are the demo scenarios which we have created. So yeah, these are the filter option, and this is the list. So further narrowing down, if you are looking for solar plus battery or only solar developer, it will there are multiple tag options which will showcase here. So if you are planning to go with solar plus battery, you will come to know that this particular vendor is working on solar plus battery. Based on financing models, that is capex and resco. If the vendor is working with capex only, then it will be shown here. If the vendor is working in resco also, then it will be shown here. We have also given this allotment of defining whether the vendor is M-panel or non-M-panel. So M-panel is which is registered with MNRE and the nodal agencies, and non-M-panel is those who are not registered with state nodal agencies. And here there will be a few more tags which will define the services that additional services that a vendor provides. So based on that, you can filter further narrow it down that these are the two vendors which I want to connect with and get quotation from. So this is the short profile wherein you will find the name of the vendor, name of the vendor, address, and website, email ID, phone number. Now, let's say if you want to look into further details or more details of that vendor, you have to just click and it will redirect you to a detailed profile page of that vendor wherein you will get the detailed information. I'm just scrolling for you to have a look of what all details we are planning. So you will get such details, and after knowing the details of the vendor, if you find that this particular vendor is beneficial for your rooftop installation, or if it suits all your requirements, then we have three modes wherein you can connect with the vendors. First is we'll provide the contact details of that particular company or particular solar vendor, like phone number, email ID, website, and there will be a social media profiles list wherein you can check their social media profiles, and if you want to connect with them on WhatsApp, you can click and connect with them. Additionally, there will be a point of contact from that particular company or that vendor whose detail will be provided here. So you can directly connect with the person personally on his phone number or on his email ID or directly on a WhatsApp. The third, the third way by which you can connect with the vendor is booking and scheduling a visit. So we have a scheduler wherein you can choose a date, and based on that date, the vendor would have some slots available. So you can select a slot and then click this request booking button. It will redirect you to booking confirmation page wherein you have to enter your personal details. After entering the personal details, you have to click on confirm, and then after pressing the confirm, there will be a thanking it will think like your booking request will be sent to the vendor, and you will receive an email stating that your booking request has been sent to that particular vendor with the vendor details. You will receive a mail, and the vendor will receive a mail, and also they will receive on their dashboard, which will be on Solsavi, that this particular user is requesting for a visit. So once that vendor will confirm the request of visit, you will get again receive an email of that vendor confirming the booking request, and then they can directly connect with you, and then you can have a further conversation with them. So concluding about this vendor portal, we have tried to compile the list of vendor for you with multiple filtering options, wherein you will save your time just by doing random, like just by browsing multiple vendors, then connecting with them individually and getting their quotes, and uh, that would, like, it is a very tedious job to finalize a vendor. So we have tried to compile the list of vendors with multiple details as like which can help you to decide which is the best vendor suitable for based on your requirements. So yeah, so these are the benefits which you are planning, and I think I would like Frano to run a poll wherein you have to tell us that whether this portal will be beneficial for you or not. So I hope it is visible. Can you please share your views on it, that whether this portal will be beneficial for you or not? Also, I would like you to raise a query on a chat box if you, or any suggestion you have for us in terms of vendor portal. Waiting for a few more seconds, and then we'll close this poll. Requesting Frano to share the result. Yeah, so we can clearly see that 75% of our user participants wants that this says that this portal can be useful, and 25% of the participants says that maybe it can be useful or not. So thank you for your suggestion and views. So I would like participants to share your queries or suggestions on the feedback. I would like to address it. I would request Rana to stop sharing the result.
Yes, Meg, I think there are some questions on the chat. I can guide you through them. I think Mr. Dorji asked if can we type one of the cities located in Northeast region, or I think he means to ask is, are the vendors only located in South India? So maybe you could explain on what areas we plan to cover through this portal when it is launched.
Yes, sure. So it doesn't have any location boundaries or something. It is for entire India. Right now, we have made profiles, demo profiles, just for just near to Tamil Nadu or something. But yeah, we can type any location. Let's say Mizoram. I hope my screen is visible. So right now there are no demo scenes created, so it will say that there is nothing found. But yeah, you can search vendors throughout India and any location of India. So we are planning to launch it pan India. I hope this answers your question. I can see that someone has requested for Andhra Pradesh.
Yes, and as you have informed, Meg, we will be trying to cover all the places in India. We will also reach out to solar developers across India so that they can register and have their information available for users from Pan India to contact and connect with them. I see another question on when are you planning to launch this? I would say that we are still in the developing stage and we intend to launch it as soon as possible. However, we think that we would require at least a minimum sign up from vendors from different location to make it live and also see the functionality of the site before launching this service. I hope that is what you are thinking as well, Meg.
Yes, it's true, Prano. So we are this is just the idea based on the feedback we received from multiple trainings. So we have tried to cover most of the points which users require. So this is what into developing phase. So once it is launched, we'll try to inculcate the vendors from different parts of India, and uh, yeah, it will be soon launched. So we have your list, so we'll be notifying each and every participants here, like whenever we are planning to launch.
I see a question from Shanti who asks, how soon will Solsavi reach common man? I think the Solsavi tool is online and the link is shared in the screen. I can share that link again with you so that you can find the link and you can use the tool. However, the vendor portal is still under development. And once we have the vendor portal live, you can use the vendor portal for finding vendors around you. I hope that is the question that you were asking, Shanti. You can confirm through the chat if you have any more queries. Meg, there is also a question from Nitin. Is there a credibility or due diligence check done on the vendors wanting to register on the portal? Maybe you want.
Sure, Prano. Yes, Nitin, eventually further roadmap for a Solsavi vendor portal is to implement vendor rating system, wherein based on their technicalities, based on the user reviews, we will rate the vendor, which will be an additional benefit for users to choose from multiple vendors. So yeah, this is also into planning, wherein will based on some vendor ratings and when based on some criteria, we'll rate the vendors. So yeah, that is also in our roadmap. Also, I can see Sandeep Raju has asked that can anyone register as a vendor for this? So right now it is into development phase, so no one has registered. But once it is live, I think there will be vendors on this portal. I can see Santi has written, and will the portal be easily usable for everybody? Yes, it will be open for all the users across India to use, or not across India. Like it will be used from anywhere in the globe. So yeah, it will be available.
However, it could be used from anywhere in the globe. However, it would have details only of vendors in India because Solsavi also does simulation only for states and union territories from India. Any other question? We invite questions in the chat so we can answer to them, or you could reach out to us on the send message in Solsavi. Maybe Meg can go to the Solsavi page and show us the send message so that they can know how if needed can be contacted.
Sure. So there is a send message space wherein you have to write the name, emails. So subject what you are looking for and the details. We'll get a mail and then we'll revert you as soon as possible.
If there are no more questions, I would ask Meg to share the last contact slide so that the participants have the contact information from the presentation, and then ask Sangeeta to close the session for us.
Sure. So you can see the contact details of Frano and my contact details. You can note it down and reach to us with any of your queries or suggestions or anything. We would give we will revert you as soon as possible. Revert to all your queries or suggestions as soon as possible.
Thank you all for participating in the session. The session was insightful, and thank you, Frano and Meg, for the session.